And author extraordinaire Eric Brynjolfsson. I know how good he is because I've written 3 books and more articles than I can remember with him.
Thanks. And joining me is Andy McAfee, who's been co-author of these books, including our latest one. You can go out and buy it, Machine Platform Crowd. And we wrote an article recently that just came out in Harvard Business Review called The Real Business of AI. And we're going to talk a little bit about artificial intelligence today.
And if you're interested, please check out the article in Harvard Business Review. A lot of the ideas that are in it are discussed even at more length, because the book is obviously a lot longer, in Machine Platform Crowd. And one of the topics that Eric and I talked about a lot and tried to get right and put in the book was, artificial intelligence is a 60-year-old field, but we're all excited about it here in 2017. So Eric, can you tell us why now and what's new and why we should be legitimately excited about AI finally?
So AI is different now than it was before. People have been playing around with it, as Andy said, for since the 1950s, really. That's when the term was coined. But now people are really talking about a category called machine learning. And that is, instead of us coding exactly what the machine has to do, writing computer code, what we do is we show examples to the machine, and it figures out on its own what the rules are. And this overcomes what we've been calling Polanyi's paradox. The famous philosopher from the 1960s said that we all know more than we can tell. We know how to recognize a face or understand a word, but writing down code for that is very, very hard.
So everyone in this audience, for example, is an expert recognizer of human faces. Nobody has been able to specify to a computer how we humans accomplish that fact closely enough, well enough so that the computer can do it. We were unable to program to code our knowledge into a computer. But all of a sudden, we now have machines, machine learning systems that are expert human face recognizers. And Eric, repeat how we're accomplishing this feat.
So the way it works is that it's an area called supervised learning, where what you do is you show the machines lots of examples. This is Andy from the front, from the side, from the top. This is a dog, this is a cat, this is a zebra.
This is not Andy, this is a human face, this is not. You show tons of examples, and the computer goes, yeah, okay, I got it.
It's exactly. They go into these things called deep neural nets. You may have heard on them. They're inspired loosely by human brains. And over here we have a little chart of how they have improved. So this is the error rate on a big database called ImageNet of literally tens of millions of images that Fei-Fei Li at Stanford put together. And humans tagged what each of those images were, like puppies and flowers and books. In 2010, machines were pretty lousy. They got about 30% of them wrong, and it hadn't really been improving much. But then you see it started improving quite rapidly, and this is when neural nets kicked in. And today, they have an error rate less than 5%, which is a key threshold, because you see we labeled it humans. Humans have about a 5% error rate on this database. So machines are now actually better than humans at this kind of image recognition.
And what's wild, like Eric says, is prior to about 2010, we were stuck at about this 30% level, and people were trying pretty different approaches. There are a lot of philosophies about how to improve here, but they weren't doing very much better. We were just kind of hanging around at this really, really way too high, very unimpressive error rate. And then just in the past 5 years, that situation changed because this approach that Eric described, called deep learning, called supervised learning, it's a subset of machine learning, has come to dominate not just image recognition, but speech recognition and natural language processing. And a lot of these areas that have been vexing the field of artificial intelligence for as long as it's existed, we're making really weirdly fast progress in them because of the ascension of deep learning.
And crossing this threshold is really important because it's a matter of degree of improvement, but it becomes a difference in kind when it's actually better than humans. So it's not just in this area, it's in areas of voice recognition, credit scoring,
fraud detection, medical diagnosis. There's a lot of evidence that these systems are now, in many areas, the world's best diagnosticians of things.
When you cross that threshold, what does that mean? It means that if you are a manager or an entrepreneur and you've got to solve a problem, you start thinking, well, what's the best way to solve it? More and more often, it's going to be a machine rather than a human. So we would love to get your questions and make this a dialogue, such as you can on Facebook. But
we
Erica,
have that technology. We can
technology.
see your questions. They will be flagged to us.
Erica
and we'd love to react to
shout them out to us. So go ahead and type in your questions, and we will explain them. But one more thing I want to say is just that this is one of the real things that's new about AI. This rapid improvement and the fact that it's crossing this threshold and the fact that we can now do machine learning rather than having us have to explain exactly what the machines do.
And the wrinkle here is that the marginal cost of one additional voice transcription or one additional medical diagnosis, when you're doing it this way, the marginal cost comes very, very close to zero. So if you're an economic decision maker, like a manager or an entrepreneur, and you're trying to figure out, do I want a person to do this or a machine? When the machine is more accurate and the marginal cost of having it do one more instance comes very, very close to zero, that decision becomes a pretty easy decision. And what we're seeing, and what Eric and I think we're going to see a lot more of in the not too distant future, are all kinds of organizations turning over tasks that are currently done with human minds over to the machines.
So while we wait for your questions, I'm going to ask you a question, Andy. We'll just check this off here. The next question is, why now? If this is so awesome, why didn't these AI guys do this 50 years ago?
And the crazy thing is that they were trying these approaches, very similar approaches to what we're using now, decades ago. I don't know about you, but I walked into this article and the research for our book with this kind of naive notion, because we kept on hearing about this weird acceleration in artificial intelligence just in the past half dozen or 5 years. I kind of had this naive idea that there was some professor at Carnegie Mellon or something who said eureka and ran over to the whiteboard and wrote down this amazing new equation and wrote this one paper that changed the entire field. And what you and I kept learning from the alpha geeks that we talked to is, no, that's actually not what's happening. It's kind of a combination of extraordinarily powerful computers that can finally make use of the algorithms that have been around, we've known about for decades. Mm-hmm. We were just underpowered. We didn't have the horses to make them work.
Right.
You go.
Well, I was just going to say, and one of the examples that Shane Legg gave over at DeepMind was that the algorithms that they're training now that take just a few days or few weeks, if you had 1990s vintage computers, they would have taken centuries or more. And so just having more computer power, and it's not just Moore's Law. You guys have probably heard of Moore's Law, the doubling of computer power every 18 months or so. It's also these new architectures like GPUs and TPUs that give 10x or 100x improvements. So that's a big part of it, is improvement of hardware. But you were going to say another thing.
The other main contributor that we keep hearing about are these oceans of data that we have. These algorithms, all these approaches are super data thirsty. One thing that Eric and I learned about the old algorithms is after you showed them enough examples, you gave them a bunch of data, they kind of plateaued. They didn't get a lot better. What we keep hearing from our AI colleagues is, man, you keep feeding these things more and more examples and they just keep getting better at telling human faces or at credit scoring or things like that. So this world of big data that we're living in is also super important. And then if there was a third factor...
Well, let me just say a little thing about the data explosion. I mean, this is a point that Andrew Ng in particular has taught us, the great data scientist and AI researcher. But it used to be that most data was in analog format, and over the past 10, 20 years, more and more information is digital. The number of digital photographs is 20 times what it was at the turn of the century. So that becomes the lifeblood, the raw material for deep learning algorithms.
All right, we have a viewer question, and our colleague Erica is going to tell us what it is.
Yes, thank you all for the questions. Please do keep them coming. We're getting a lot in. So here's a question asking about social context. Who will teach AI the difference between right and wrong based on social context?
Yeah, we want to talk about that a little bit later on. We talk about risks and concerns. You want to do it now?
We can do it now.
We're gonna, fine. We're going to get jazzy here. We're going to skip from our highly structured 4-point outline and dive right down. All right, fine. Let's talk about.
Okay. We have one more point to make here. Let's just make it now, real quickly.
Make it.
Which is the last one, is that the third thing is algorithms. It's not like there was one big breakthrough eureka, but there have been improvements in the underlying algorithms that have also mattered, the techniques that the scientists are using. So these three things together explain why now. But this is a good lead into the other point. These algorithms, while they're very powerful, they also can make problems and sometimes make the wrong decisions.
And when we talk to our AI colleagues, they tend to stress the first two, and I actually think they're being modest. There is a huge amount of really brilliant tinkering going